In this lesson we're going to look at properties of logarithms, but before we do we really need to review our properties of exponents. So what does a negative exponent do to the base? As in, how can we change a negative exponent to a positive? Well, you take the reciprocal of the base and change the sign of the exponent. So that would become 1/8. When you have something other than 0 raised to the power of 0, it always equals to 1. When you have a square root, you need to remember that that is 7 raised to the half power. The bottom number is the root and the top number is to the power. So that was like 7 to the first square root. So if we have the cube root, that's 11 to the 1/3 power. This last example kind of combines some things. So we know this is 1/6 to the half power. But how can I write that 6 to what power? If we come back up here, in order to take that reciprocal of the base, you have to change the sign of the exponent. Now all of that should be a review. So let's kind of go on toward logarithms. How can we compare exponents to logarithms? Well, you have to just write them in a different form. If we have 2 to the 3rd power equals to 8, this is written as log base 2 of 8 equals to 3. So we have the base, so log base 3 of 1/9 equals to -2. Now before we work this one, we need to write that radical as an exponent. So 81 to the half is equal to 9. So we can write this as log base, what's the base? 81 of 9 equals to a half. On this one, again we would rewrite that as 27 to the 1/3 is equal to 3. So we have log base 27 of 3 equals to 1/3. What do all of these logarithms equal to? They equal to the exponents. Very key. Logs equal exponents. That's why it's important to know your exponent rules so you can relate it to the logarithms. So on these, can we go backwards? Can we write this in exponential form? Sure you can. So we take the base, raise it to the exponent, and what does 2 to the 4th equal to? Of course it's 16. So here we have the base raised to the exponent, and that equals to 1 over the square root of 3. Convince yourself that that's true. Look at that example at the top of the page where we had 1 over the square root of 6. Now we're going to evaluate some expressions. Your calculators only do base 10 and another base that we're about to talk about. We don't need a calculator though, because we know our properties. So if you kind of imagine that this is saying what does that equal to? It is saying 7 raised to what power equals 49. Remember, your base raised to the exponent equals to 49. Well, 7 raised to what power is 49? Well, of course it's 2. So this is saying 3 raised to what power is 27. Well, if you need your fingers and toes, go ahead. But it is 3. 3 to the 3rd power is 27. So the answer is 3. This is saying 6 raised to what power is 1/6. Now look at that. Look at how the base is the reciprocal. So what kind of exponents take the reciprocal of bases? Has to be negative. What's that power to? 1. So if the bases are reciprocals, think negative. So here we have 3 raised to what power is 1/9. Again, we have a reciprocal, so we know the answer is negative. And then just kind of look at 9 and say, all right, 3 to the what power is 9? 3 squared is 9, but we need to make it negative because the 9 was in the denominator and the 3 is in the numerator. That's like 3 over 1. So here we have 6 raised to what power is the square root of 6? Well, you have to think about, what does that square root mean? It's the half power. So we're saying 6 raised to what power equals 6 to the half power? Well, of course, it's 1/2. So we have 3, which is the base, raised to 1 over the square root of 3. Again, we have reciprocals, so we know the answer is negative. What's that square root on that 3 mean? 1/2. Alright, so now we have 81 raised to what power is 9? Now you're going smaller. That's not the reciprocal, smaller. Did we just do something here at the top of the page? Was that something familiar? It sure seems like it. Right up here. Okay, and what did we have? We had a square root. That's right. The square root of 81 is 9. So if I need a square root, what's exponent is the square root? Of course, it's the half power. Now, 12 raised to what power is 1? Look at the top of your paper. Look at that example where we had 5 to the 0. It's going to be 0. 12 to the power of 0 is 1. Any number except 0 raised to the power of 0 equals to 1. So that's how you can evaluate without a calculator. Now, our calculator has two different kind of bases. It has base 10 and base E. Base 10 in 99% of the textbooks are written like this. It does not have that little 10 as a subscript. It is assumed that it's there because base 10. Why is base 10 so common? You have 10 fingers, you have 10 toes, we have powers of 10s in our number system, such if we have 1,000, that is 10 to the third power. This is the ones place, that's the tens, hundreds, thousands, and so forth. So our numbers are in base 10. Right, so if you want to know what log of 10 squared is, you're saying 10 raised to what power is 10 squared? Duh. 2. So as long as this base and that base is the same, that's easy. So we're saying 10 raised to what power is 10 to the 5th, but the square root of 10 to the 5th. How can we write that square root? As the half. Then remember our properties of exponents, so you can multiply that. So that's 5/2. So this answer is 5/2. Kind of take a minute, soak up that, see how it's going. But look, if the bases are the same, it's just the exponent. Bases are the same, it's just the exponent. Now, the other thing that's on a calculator, a scientific calculator, would be the natural log. And that is abbreviated as LN. Yes, on your calculator it looks like that, so some people think that's an I or a 1, but it really is an L. They somehow switch that. I don't know why, but it's base E. We talked about what E was. E is approximately 2.718, just a number that you're going to run into as you are in your math career. So when you see LN, that's really base E. So we're this problem saying E raised to what power is E squared. Again, if those are the same, it's just the exponent. So we're saying here E raised to what power is 1 over E. Well, remember, the bases are reciprocals. We know the answer is negative. Then what power is that? -1. This one's saying E raised to what power is the square root of E? Well, what's that square root power? You should know it by now. 1/2. So you can see there's not a lot of work to show. It's just facts you need to know. Logs and exponents are inverse functions. They undo one another. We saw that in our graphing of those two functions. And we have these two properties. Remember, they're inverse functions. If you put in x, you get x out. So this says log of any base of the same base raised to the power is equal to x. This one's a little bit stranger. We have a, which is the base, raised to log base a of x equals to x. Let's see if we can put that in action. All right, look at this property, and we really just did this. You're saying 5 raised to what power equals 5 squared. Now you can go through the long way, or you can just know this property that says if this base and this base are the same, you're just going to get the exponent because they undo each other. Same thing for the next one. This is really base e. That natural log is base e. And since we have this base and this base are the same, just like this one and this one, they undo each other and you just get 3. What about this property? What do we have? We have base 7, just like a. We have log base 7, just like here. So what does this equal to? 5. Again, those bases have to be the same. The next example is exactly the same, believe it or not, because we have base e, natural log is base e. There's like a little bitty e there, we just don't write it. So what is this equal to? X. The next one we have base 4, 11. Now this one looks a little bit different. Okay, so what base are we in? If we see just log, it's base 10. They're saying 10 raised to what power equals 1,000. So that's kind of how we were working it out earlier. Well, what power? Is it 10 to the first? No. Is it 10 squared? No. Is it 10 cubed? Yes, it is. So these are very good properties to know. Helps you save yourself a lot of work.